Hello, everybody. My name is Nathan Parker. I'm also known as King Pro 7 on the web. And a few days ago, I just finished a Python project called Stoichify. Stoichify is a stoichiometry solver which helps chemistry students actually take their problems and actually give them work for the real solutions. So, I finally decided to publish it on GitHub as it was a requirement for the project. Because I did this project for Ivy Tech, which is a local, kind of community college in Indiana, and I'm like a dual credit student, so I'm doing this on top of high school. And for our final project for Intro to Software Development, I decided to make this. And the main goal of it was to, take freshman high schoolers and actually uh, get their answers to their stoichiometry problems. Because with stoichiometry, um, there's a lot of things you have to build on top of. So you have to know elements, right? And then you go through, basic elements. Then you go through subscripts, like gases and stuff, how they're not one, they're two. Then you have to go through polyatomics, so charges, and then all these different other types of stuff, and then you actually get into stoichiometry with balancing the chemical equation, and then taking one mole of something into grams and into representative particles and to uh, all these other measurement units, right? So this just basically packages all that together where a chemistry student, can input their givens and then turn them into wanteds and show all the work being done during that process. So I built this. So the first version I made, I actually this idea was about a year ago. I made it for a computer science 2 class in high school, but it wasn't really that good. It actually kind of sucked. It was only moles to moles, and it was like a CLI type of like Python thing. But that's when I had pretty low Python experience. But now, since I've done other college classes with Python, I've been building up my Python experience, and I finally began to make this one, which is version 2. And version 2, obviously made for Ivy Tech, is a GUI application, so it's no longer a command line interface project. It's now a fully fledged, interactable Python uh, project. So this is the GitHub for it. You can just search up kingpro7/stoichify, or I'll link it in the description. So this is the whole code base. And I outlined its capabilities for you now, so we can parse substances, equations, special characters, concatenation, and other string inclusions, which you'll see later. We can find elements, element subscripts, multipliers. You can I can finally check for element validity. So if you write an element wrong, like ln, it it's not like a real element. It'll check for that. Significant figures, which is a pretty big one. Um, when you're regularly writing out like a float, Python actually strips out like trailing zeros, even if they're significant. So with that, you can't get all the significant figures because Python thinks they're insignificant. And with the way floats are stored in computer memory, it's just you can't fit all of it to the exact, every single thing. But with tk-enter, which is what Stoichify is built on top of, uh, it actually, when you input into a like entry box, it actually saves every single thing into a string representation. So utilizing that, you get all the digits, and then you can count them with a custom built significant figure counter I've made, and now you can actually get that. So if you're doing this, like if you're trying to convert Stoichify into this like CLI type of program, if you adapt it to that, it's kind of hard to get that. So just keep in mind, if you're a programmer, um, in the code, I've made every single docstring, and with the Stochify one with an equation or a substance, which I'll get to later, you have to put in the given significant figures, or unless you build a string representation of it. So just keep in mind that. I also built Stochify to also accept different types of scientific notation. So this is a regular scientific notation for like floats, like what a computer would generate. So it accepts that, accepts this one with just an x, actual multiplication, accepts negatives. So scientific notation, when you're trying to parse it, what Stoichify does, it takes these representations right here and then parses it to the float representation. It doesn't matter if you input the float representation first off, it'll just convert it anyway. So it converts to the float and then it converts it back into a presentable scientific notation. So, scientific notations are really hard to like standardize, so I accept multiple different representations of way you do it. Um, and then Stochify can obviously balance chemical equations because with stoichiometry, I can't say it no because I keep saying Stochify, but stoichiometry. To do stoichiometry, you have to have a balanced chemical equation. So if you do the equation route, you have to have you can like input an unbalanced chemical equation and Stochify will automatically balance it for you. So that's pretty neat. And then obviously with you can convert from measurement units and then while all this is happening, it shows all the work, which is one of my big upbringings of this, is it actually shows it in fraction form as you would write it on a piece of paper, right? So that's one of the big plus that I think what sticks like sets Stochify apart from all the other geometry tools online that use like are built with JavaScript on the web. They just give you the answer. Stochify just shows you all the work with it too, so it's a really big plus. And then you can take multiple ways. And then if you're a programmer, if you're really good with command line, I have all the steps for you to install this on your own machine, or you can do whatever with whatever. You can apply this. You can turn it to a CLI. You can build upon this. Do whatever you please. Here's all the instructions. All this is written out for you if you want. Or if you're like a chemistry student, you just don't want to do all this, or you're just lazy, I made a compiled zip right here. Or you can go to the releases and download it, and then you can just open up the zip file and click the executable. Pretty simple. And then I also made, as another requirement for this project, a full PDF user manual. It's not with the installation instructions, but actually how to use the GUI application itself. So I'll get to that, but also here's the contributors, they're here as well, and then some license information. Just Stochify, you can basically use it for whatever you want, but just know that Stochify is meant to be free. It's meant to be used for everyone. So just keep that in mind. But I want to give you guys an example or what the user manual looks like. So this is the user manual I have to get up here, and this is a 21-page user manual that I had to make and had to submit as a part of the project for the college. So here it is. It just tells you how to use it, what the GUI interface looks like. It has you can navigate to all of these if you download it and open it yourself. So I have all these. It shows you what all the buttons do, what the other page is, what the different routes you can do. It basically labels as in stages, so there's 4 stages. So you go through, it shows every image, it tells you what accepts, what like each inbox or input, what it has, what its drawbacks are. So that here's some examples of what is accepted in the equation one. It shows you what all these other ones, all the other stages, what all the drop downs are. It shows you like the results page. And one of the big thing that I had to do for this project is actually test it. So I had to write 60 test cases. It wasn't like a minimum test case requirement, but upon finishing this, and I did the testing after, which was kind of a big problem, which I note in here, but I do 60 tests, so it does all the inputs and all the, answers and stuff. So I made this, and then I also had to compile from what sources I use. So these are all the sources I use, basically. There's some other ones, but they're not really too relevant. They were just more to relearn uh, how to do stoichiometry. So I give you all that, and then I show you each and every like example that I kind of use to base and build Stochify throughout its software development process. So just show you, explain it some. You can just see side by side where I got it, what the actual answer is. You kind of compare, like zoom in. So like this one, it was getting from this one right here. So you can see like this is an honors chemistry like PDF that I found randomly online. Uh, you can just kind of see how they look very similar. Um, so it just shows you, Stochify in action in real world, PDFs and YouTube videos. And then obviously here's the contributors again. Thank you guys. I have my teachers and stuff. I have all the libraries that I use, people that made certain algorithms and stuff. So big thanks to them. Without this, Stochify wouldn't be a big deal. I wouldn't even be made. So big thanks to you guys. It wouldn't be possible. Um, and with that out of the way, um, I will now get onto the code. So let me just go over here. And so this is the main.py that I have here, which is just the where the GUI takes place. So this is where you see classes and stuff. And each I want to note, um, if you're if you're a programmer or software developer and you want to change Stoichify and add on to it, each method that I've ever written has uh, doc strings, it has inline comments, and it has section comments. So if you're confused or you don't know what things mean, they're all right here for you. So if you're typing it out or you're just hovering it, it'll show you the doc string right here so you can actually see. And all parameters are also labeled or returns. So if you need those, they're all there for you. And if you still don't understand anything, just contact me on Twitter or Discord. I'll be happy to help you. Uh, but this is, you can just see how much work I had to put into this. This is all just a GUI. This isn't all logic. Uh, like making buttons with TK Enter and a custom theme. It's, you know, I really wish I could make this in HTML and CSS, but we didn't because we're supposed to build on top of our Python experience. So, you can just kind of look through this if you guys want. If you download the zip properly and unzip it, this is what you'll get. If you don't download well, if you download the compiled version, you just get .exe, so you don't see the code. Uh, but if you do download the zip from GitHub, you can see all this, which is just main. This is just main, so this is the GUI, 612 lines, and then you can get on the other 4 or 5 Python, uh, I want to say modules, but just there are other scripts, and all of them are class-based and object-oriented. So you can just see, this one deals with actually converting like to moles to grams, does the molar bridge, it does measurement conversions. That one's responsible for that. You can see how much doc strings I had to do, and every one of them has header comments with their last modified date. Uh, and here's the test cases one. So 60 test cases testing against inputs from answers to parsing scientific notation or floats or significant figures. Testing instances. Here's some section comments. You guys can look through that if you want. Fixes I made along the way. I made just kept note of that. Precision. Taking account into scientific notation, significant figures, parsing them to floats. Here's the significant figures one. You're parsing them, or you're counting them, or you're rounding to them, which is also another big part. If you have if you input I have a measurement of 3 significant figures, that's what you want to round to. So it's also a big part. And then this one, the biggest script of them all. Uh, if you're, a programmer, keep in mind there's doc strings to help you. If you don't know, please contact me. I'll be happy to help you. But you can create instances of equations or substances, which I'll get onto later. But you can just see how many methods I had to do. So there's element scans. You have to scan through substances as well to check through parentheses or brackets, or check for oxidation reactions, which aren't supported unfortunately by Stoichify because there's some different balancing that my chemistry teacher noted. So when you get you keep diving down into uh, you know the processes of doing balancing chemical equations and converting. So this just deals with probably most of these. You can see that there's a Stoichify method which is appropriately named, and it calls the Stoichify class. Here's an equation. So that was just you were looking at the substance class, now we're looking at the equation class. You can see have type checkers. I have to remove substance states with like grams, or if it's you do like if you say the substance is a solid, you have to remove it, and then I have to add it back in. There's so much string parsing here, it's not even funny at this point. And uh, here's some like the testing that I had to do. They're obviously commented so it doesn't interfere with the console logs if I do have any other. But you can just see how much This kind of had to do. Um, and you can look through that if you want. If you need any help with modifying Stoichify to your needs, I'm happy to help you. Um, but if you do, you know, execute the executable in the releases file, or you actually build it and run it in Visual Studio Code or your main IDE, and you do that, you'll get this window. So this is the main window of Stoichify, and we also had to do a second window for some reason. So just here's like a different window just to show you if you need help. Go to GitHub and some contributors here. But this is kind of like your nav bar, and then this is a banner. So this banner will always show you, information how to input. Or if you're not sure, just please go to the user manual right here. I made it for a reason. And with Stoichify, you can take two different routes. You can do an equation or a substance only. So with an equation, you're kind of expectant to have like concatenation of like substances, or you have substance that, like goes into other substances. You're basically supposed to have more than one substance. But with substance only, let's say you just want to go from, I don't know, 15 grams of fluorine to how many moles is that? Or you have, water, how many grams of water is in representative particles? You can do that. But with this particular example, I'm just going to do an equation. And this one's also in the testing here in the user manual. It's just this one right here, which I'll be showing you. So when you're inputting it, it tells you, what it expects. And if you do copy from a website, I do account for that. So if it has subscripts, it changes the subscripts to integers to pars, or if you include substance states, or you include a different unique type of arrow, the website could use some weird Unicode one. Or if you just write an arrow with a dash and a greater than sign, that also parses. So this is just meant to, parse it into where I have to kind of standardize the equation so it can be parsed and you can check for things. So let's just say you want to input this one. So let's say I have this equation right here. Right here. So that's kind of how you do it. There's no pasting of subscripts. You don't need to copy from some website. You just input them right here. I've made it super simple. Don't really worry about it too much. If you do get an unknown error and it's not listed anywhere, please contact me. I'll fix it for you. But yeah, that's how you would input it. It also, if you had like this, it also accounts for that. So this 3 would be distributed to the sulfur and the oxygen, there's so many off cases, and Stoichify will handle most of them, not all of them. Stoichify isn't perfect, but here's that. And let's say this is what it is, and there you go. It actually parsed it, and it actually balanced it for you. So these coefficients are the balanced correct coefficients. You can check online, and it actually did that for you. And now you're in the stoichiometry state, where you now have to input your given amount, given measurement unit, the substance you're given, and then to the wanteds, right? So then what do you want the wanted measurement unit to be? So if you're going from grams, do you want to go to moles or representative particles or grams again, and then the substance that'll apply to it. So this example is 3.4 moles of SO2 to this one says moles of SO3. So boom, like that. You don't really have to type it because I made it. I try to make these as smooth as possible. So for that, I just chose to do drop downs instead of having the user try to input it again, because that's just more work on my side. And these automatically get the substances, so it's just kind of a nice benefit. And after doing all that, you can just click the Stoichify button, and boom, there's all your work shown out for you. It shows what the given and then to the wanted. So you can see from the molar bridge, all that. So then I was like, upon testing Stoichify, I was really realizing that the way I had it before, I didn't have this restart stoichiometry button. So it was kind of hard to keep typing this out. So I thought I would make this more of a looping type of project. So you can actually do this and do more, you can do more stoichiometry with this. And it's personally one of my greatest features. It's one of the smaller features, but it makes this process so much better because I was looking on more worksheets online, and I was realizing that these problems that chemistry teachers give out, they typically take one equation and then you do multiple conversions. So that, aids that. And if you want to keep doing it, you can keep going. You can do like, let's say 55 grams of oxygen, and I want to get to, liters of SO3. You can do that, and you can see more as like the more complex it goes, the more fractions it adds, because that's how many conversions it's doing. And you can see the work like it would be like a student would or a teacher would on a piece of paper. So I think that's the main benefit of Stoichify. You're not just given an answer. You're just not like left in the dust. You actually see the work, you see the values, and you can see what's being done and what you get. So um, you can keep going, or if you completely mess up, you can click the restart button up here. You can go to a different one. So I'm also going to show off the substance version as well. So this one's from a honors chemistry like PDF that I found. Uh, so you can go in here, and so you click substance only, and then this one is oxygen chloride right here, or it's like mono oxygen chloride or whatever. I forget how you say it, but this one, it takes 392.1 grams of this oxygen chloride. And see, it's already filled out for you because it knows that there's only one substance. And then let's say you want to get to represented particles, and boom, there's all the work out for you. And if it's a little small, you can just kind of enlarge it if you want. It's not going to ruin anything. But you can see all the work out for you, and it, correctly parsed scientific notation for you. And because of that, I'm also going to show you with another substance, inputting scientific notation because I think that's really important to show off. So here is this substance right here. Should I type it right? Boom. And it shows you right here, it's all big. If you have an equation, be balanced. And here's some of the instructions. So you can also include the, I think that's called a bracket or like a caret. I think it's a caret sign. And you can do that or the float form. Doesn't really kind of matter. Or you can do like times 10, like that. But this one, I'm just going to do 3.902 times 10 to the 28. So that's probably how a regular student or how many other people would write it. So then this is represented particles. Since this is a substance, it's already filled out for you. And this particular example goes to also grams, and boom. So see, it's a little too big. If you can always resize it. And there you go. So there's parsing scientific notation. It rounds. So you see 1, 2, 3, 4 sig figs over here. It also rounded to 4 sig figs over there. Um, and yeah, that's kind of Stoichify in action. You can kind of see that there. Uh, there's many more examples that teachers might give you. Some might, have one conversion, or some have many more. Uh, Stoichify hopefully will handle all of those, and if it doesn't, I'll make sure to fix them for you guys. Uh, I'm not sure many people will see this, regardless. But if you guys have any problems with Stoichify, I'll be happy to solve them for you. Just contact me on Discord or Twitter or whatever you find me at. Um, if people blow this up and they want the CLI versions, or you want a code documentation, I'll definitely write that for you guys. Stoichify is meant to be like an open source. This is for the public. I don't close source these projects. I don't do these projects just for like one assignment and they're done. Uh, I want Stoichify to be for the public. It's kind of like what brings me to coding and stuff. And if you guys find this useful, please start, share it with your friends, share it with your chemistry teachers. I'm sure they'll definitely enjoy seeing, some student in random America, just, apply their knowledge from, like, this is applying knowledge from high school and college and from two different subjects. So, just share it with your friends. If the interest builds, I'll continue supporting it. Just I hope you guys like it. And if you guys have any questions, please let me know. If you have any issues, I'll definitely fix them right away. And yeah, that's Stoichify. If you liked it, you know, please start on GitHub. It would mean a lot. And yeah, so that's Stoichify. Thank you guys. See ya.